Hello Caymans, Mr. Eicher here. We're looking at lesson 2-3 today. If you don't have these notes printed out, I'd encourage you to print out those notes, or at least take a piece of paper out and follow along. You will be able to use your notes on the quizzes and tests or anything like that up ahead, so it'll be helpful for you. I think most of this lesson on slope and rate of change will be things that you've learned before, so hopefully it'll be a good review. Maybe you'll learn a few new things. But the first thing we have is if you drive at a constant speed or rate of 60 miles per hour, what distance will you travel over the specified times? So after 1 hour, you will have traveled 60 miles. If you're going 60 miles for every 1 hour, 60 miles per hour. If that's a constant rate, then you will have traveled 60 miles. After 1.5 hours, you will have traveled 60 miles plus half of 60, so 90 miles. After 2 hours, you will have traveled 120 miles. 2.5 hours, that's 150. And 3 hours going 60 miles per hour is 180 miles per hour. So that's our speed or our rate, our total distances that we have. And we can graph this. Let's start, we'll use this as our X and Y axis. So our X axis is representing time in hours, and our Y axis is representing distance in miles. So then graphing our first point, I need a scale next. So our scale will be, we'll make this 1, 2, 3. So this would be 0.5, 1.5, 2.5. Our y-axis goes all the way to 180, so let's see how we can do that. Maybe we'll go 60, 120, 180. Maybe we'll make this 180. This would be 90. Half of that would be 45. And this would be 135. So counting by 45s on our vertical axis. So then graphing our points, we'd graph the point 1, 60. So that's right about here maybe, 1, 60. We'd have 1.5, 90, 2, 120. 120 is about here. 2.5, 150 is about here. And 3, 180 is about here. So that would be our rate of change. If we left it as individual points like this, with no connection between them, that would be a discrete graph. But this is continuous. You can't jump from 60 miles to 90 miles without going all the miles in between, 61, 62, 63, all those. So we actually have a linear function. This is a one-to-one linear function. We'd keep going. We'd assume that it would continue this way, but we'll just graph that. So that would be our the graph using our rate of change. Now the next question, we have a little table here. And it says the table shows the temperature of a solution. After it's been removed from a heat source, find the rate of change in the temperature for the solution. So to find the rate of change, we'll start with what the temperature was initially. It was at 0 minutes, it was 143.6. And then at the end, it was 118.4. So how much did it change? Well, it went from 143.6, and then it ended at 118.4. So subtracting these, we would get 25.2. So the temperature has changed 25.2, but we need it to be a rate. And a rate is going to be how many degrees did it drop in how much time. So it started, it's dropped 25.2 degrees in 12 minutes. So what we could do is, as a rate, we're going to divide this by, it started at 0, then it ended at 12 minutes. So this is degrees Celsius. This is minutes for our units. So we would say 25.2 divided by -12 is -2.1. So we would say the temperature is dropping an average of 2.1 degrees Celsius per minute. So as you can tell from the table, the temperature is dropping, so that's why it's negative. And the units are degrees or temperature per minute. And we could use the same idea on the next one. The graph at the right shows the number of gallons of water in a swimming pool as it's being filled. At what rate is the pool being filled? We're given, helpfully, we're given two ordered pairs here. So let's use those. Our rate would be water in gallons divided by time in minutes. So we would have it's ended at 252. It started at 108. Those are our water in gallons. And it's been 7 minutes once it's gotten to 252. And it started, or the point we're using is the 3,108. So subtracting those, we would get 144 over 4, which is 36 gallons for every 1 minute. Or you could write it as 36 gallons per minute. And those units are pretty important. Sometimes we forget to include units, but the units would be 36 gallons per minute. So in these three questions that we've dealt with on this page, we've been calculating what's called the rate of change. Rate of change. And the rate of change is simply a ratio being fraction like we had there. Ratio, these are all ratios, that compares how much one quantity changes on average relative to the change in another quantity. So when we're doing the rate of change, graphically, when we were doing the rate of change, we were doing the change. We use a little triangle for change. The change in y over the change in x. Change in y over change in x. A little triangle. In math, this little triangle we say is the change. Change in y over change in x. So the change in y, we subtract the two y coordinates and divide that by the change in the x coordinates. Now on the second one, I started with the ordered pair over here, whereas on the first one, I started with the other ordered pair. It doesn't matter what order you choose, which point you want to start with, as long as you're consistent. So the y2 and the x2 should be in the same position, whereas you could also do it like this: y1 minus y2 divided by x1 minus x2. So the one that you don't want, the one that would be very unhappy and you'll be getting the wrong answers, is if you did something like this: x2 minus x1, y2 minus y1. Don't do that. It has to be the y's in the numerator, the change in y over the change in x. The other one that would make you very unhappy, because you'll be calculating it wrong, is if you mix up. Say if you do y2 minus y1, if you did x1 minus x2, that will also, don't do that, that will also give incorrect answers. So those are the two most common mistakes. So you can look out for those. And really what we've been doing with rate of change is the same as the slope that passes through 2 points. So to find the slope, if you need to, you can always label these. This one's x1, y1, x2, y2. The letter that we use for slope is an m. So if we did y2 minus y1 divided by x2 minus x1, that would be negative 13 over negative 1. So our slope would be 13. Now there are no units here, but this would be the change in y over the change in x is 13, or 13 over 1, but we'll leave it as 13. The next two questions are try thises. As you can see, the little circle here indicates it's a try this for you. I'll see you in the next video.